In this question, we have this function g of x is 5 times x plus 4 squared minus 7. We want to find the domain, range, and vertex, and determine if it's a minimum or a maximum and what that is. So let's take a look at that function, and let's do some analysis. So this is written in the general form of a quadratic function, which is a times x minus h squared plus k, where the vertex is h comma k. So in this situation, what can we see? We can see that the h, x minus h, is x plus 4. So if that's the case, h equals -4, k is -7. So the vertex that we have will be -4, -7. And what is the shape of this graph? Well, if a is positive, the parabola will be opening upwards. So that tells me that there will be a relative minimum at the vertex. Let's take a look at the graph to make sure that we're seeing this correctly. So we can go back to Desmos. And look at it. So we've got g of x equals 5 times x plus 4 squared minus 7. And we believe the vertex should be at -4, -7. Is that what we see? -4, -7? Sure looks like that. Now, what do we say about the domain? Again, it's a parabola. The domain is all real numbers, x values. Any x value you want, it'll eventually get there. It grows, goes to the right, goes to the left. So our domain here is all reals. So our domain is from -infinity to +infinity. Now, how about the range? Well, again, we saw this was our graph. So the lowest y value we have is here. That's the y value on our vertex. So our y values are this y value and higher. So our range is y is greater than or equal to -7, which in interval notation would give us from -7 to +infinity. And we can see that on the graph. Indeed, y value of -6 hits in those 2 points, -5 hits in these 2 points, y value of 3 hits in those 2 points. Any y value you want, right? 10, we have a y value of 10 here and a y value of 10 there. Any y value above -7 is going to be okay, but -8 is never on the function. -9 is never on the function. So -7 to infinity is our range. Now, what does the function achieve? It achieves a minimum of what? Of -7. So we'll say the function achieves a min of -7, relative min. The function achieves a relative min of -7, where? At x equals -4. If you want to say a relative min of y equals -7 for emphasis, that's not a bad idea. Go ahead and show the graph one more time. Function achieves a relative min of -7, where? At x equals -4.